Hello class 9C. In our previous classes, we are learning about how to solve the numerical on Charles law. And in last class, that was on Friday, I uploaded the solutions of 3 assignments. And I hope that you have gone through it and have done the correction wherever is required. Now, today we are going to see once again the numerical in Charles law, but this is slightly different from whatever we have seen before. Okay, so first I'll solve one example, and similar kind of example I'll give you for an assignment. So say for example, the question is, at what temperature will 500 centimeter cube of a gas measured at measured at 20 degrees Celsius occupy half its volume, the pressure is kept constant. So you're asked to find out the temperature, okay, the value for T2. Just remember what is given. Volume of a gas is given, the value for V1 is given 500 centimeter cube, and the temperature T1 is also given, okay, 20 degrees Celsius. And you're asked to find out the temperature at which the volume become half of its volume. Half means previous volume is 500, so half it becomes 250. So and you are asked to find out temperature, so let the required temperature be T degrees Celsius, okay, because we'll be finding the temperature in degrees Celsius only. The pressure is kept constant, okay, fine. So volume V1 is 500 centimeter cube, the value for V2 is half of that, 250 centimeter cube. T1 temperature is given 20 degrees Celsius. So while doing the numerical, we always convert the temperature into Kelvin. So we'll add 273. So 20 plus 273 will give you 293 Kelvin. Fine. Now we have kept the temperature, required temperature that we need to calculate as T degrees Celsius. So the final temperature T2 will be 273 plus small t, that will be in Kelvin. Okay. Now since the pressure is kept constant, we can use Charles law, which is given by equation V1 by T1 equals to V2 by T2. Now substituting the values, we'll substitute the values. The V1 is 500, T1 is 293, V2 is 250, and T2 is 273 plus T. Now what we'll do is we'll just cross multiply it, simplify it, and we'll try to get the value for T. Okay. Finally, when you simplify and find out the value for T, it will come as minus 126.5 degrees Celsius. So this is the temperature that we require to calculate. So the gas would occupy half its volume at minus 126.5 degrees Celsius. Fine. In a similar way, please solve this assignment, which is assignment number 9. Question number 1 is, a certain amount of gas occupies a volume of 0.4 liter at 17 degrees Celsius. To what temperature should it be heated so that its volume gets doubled, pressure remaining constant? Over here also you have to carry on in a similar way. V1 is given 0.4 liter. The value for T1 is also given 17 degrees Celsius. You are asked to find out the value for T2, and it should be in degrees Celsius only, so you can assume as small t degrees Celsius. And the volume becomes what? Doubled. That means it is 0.4. So when you multiply with 2, it becomes 0.8. Okay, 0.8. So the final volume will be that one. So you calculate the value for T in a similar way as we have done before. The question number 2 is, the volume of a given mass of a gas at 15 degrees Celsius is 100 centimeter cube. So the value for B1 is 100 centimeter cube, and T1 is also given 15 degrees Celsius. To what temperature should it be heated under the same pressure so that it occupies a volume of 125 centimeter cube? So the final volume becomes V2 as 125. So once again you are asked to find out the temperature T. Okay, so in a similar way you just calculate it and get the values. That will be the, and don't forget to write down the unit because you're calculating the temperature, and in the question it is mentioned degree Celsius. So at the end also, when you find the temperature, you should be aware that it comes into degree Celsius. Okay, complete it and